in the lecture, and you have to concentrate in everything. So then only you can get these examples. Okay. Okay. From the above example, one of the examples, say here, x equal to, okay, so x equal to 45.293 to 4 digits. Also, you have to know w is equal to 4. So they are right. They have written in this because okay, one of the student have asked the questions. Can we write this one something 0.045 times 10? Okay, so rather than that, so if they given you in this way, for example, this way, you have to make it into 0 point that one. Okay, you have to push it into this way to 0.45293. So how many times, how many digits I have taken this way? Okay, 1, 2. So this will be 10 to the power plus 2. If you are taking this, so for example, I already have this, only this one. Okay, so when you are writing this one, you better can write this way or other way. Yes, that is one of the students' questions. So you can write this one like 4.5293 times 10 to the power 1, I mean minus 1, I guess. Yes, or 0.045293 10 to the power, I mean 1, I guess. So even though we know in the significant figures, we don't consider this leading, no? So we're going to consider this one. That is also correct, but better you choose this one. Okay, something we don't put 10 to the power 1, no? Something 10 to the power 2, 3 or something, or 10 to the power minus is fine. Okay, so this is also correct. Not I can't say it is wrong, but this is somewhat good to see. Okay, so if you are writing this way, only problem is if you are writing something like 0.045293 10 to the power 1, you may sometimes take this one also 1 digit. Okay, if they say 4 digit, you'll take 1, 2, 3, 4 like that. There may be a mistakes comes. So that's why I prefer this way. Okay, so that's the only problem. Okay, now let's do this example together. So question is about, this is a x. Okay, they are asking you to chop it 4 digits. So we have w is equal to 4. So I can write this one as 0.45293 10 to the power 2 as a, what is that? I mean, floating point number. So therefore, n is equal to 2. So that's this one. Then absolute chopping error is bounded by this. So 10 n minus w. So what is will be 10, 2 minus 4 will be 10 minus 2. This will be 0.0. This is like 10 minus 2 will be what? 1 over 10, 2. This is like a 1 over 100. 1 over 100 will be 0.01. So I think you know these things. Okay. So then therefore the absolute chopping error is, okay. So the, okay, this is given. Okay. Actual, let's calculate the actual. This is the upper bound. Okay, this is the upper bound can be this much of tolerance, 0.01. But actually our absolute chopping error can be calculated. Delta is equal to modulus of x minus x star, which is equal to, what is our x? X this one. X star will be, what is that? X star will be, if you cut out 4 digits, 1, 2, 3, 4, the 3 will go out. So this will be, so if I write in the floating point number 2.99, sorry, this will be 45.29, isn't it? So if you use this one x star, then the answer will be 0.03. Okay. Yeah. So if it is 0.03, this is our delta less than our upper bound. No, this is our upper bound, 0.01. 0.03 less than 0.01. So correct? No. 0.03 will be greater than. Am I right? Please answer me in the chat. 0.03 greater than 0.01 or less than. Which one is correct? Anyone? Okay, this the idea. First means what? It's greater than, isn't it? So there may be a mistakes. So it should be, yeah. So this is like 1 over 300. This is 1 over 100. Okay. So if the denominator bigger one, the answer will be, am I right? If the denominator, the 1 over 300, sorry, not 1 over 300. Okay. So this will be something, it should be like this. Okay, there is a mistake. So you had to have the estimate is not, you can write not. Okay. Okay, someone has, okay, good. Enough, okay, fine. Then the question is fine. Okay, thank you for your answers. Okay, this is should be 0.003, no? Okay, good. So if it's so, this is correct. Okay, 0.003 less than 0.01. Then fine. Okay. Therefore, we have to write the estimate is absolute is accurate. So this is acceptable. That is what it says. So estimate is absolute accurate. Please write down these answers, okay, in your note. If you are writing the draft, you just put the heading and write the examples one by one. So when you are writing, you can write nicely in the notebook. Okay, thank you for this one. This is good. Okay, fine. Okay, shall we continue? Okay, there is one exercise. Example number. Okay, this is your exercise. Can you try? I'll give you 1 or 2 minutes. Can you try the example number 3, which was given earlier? Okay, this one. Let's go back to the chapter. Yeah, this one. I think the same question, no? Okay. And example one, I think one is we have done now. So you can try the second and third also as exercise. Can you try? I'll give you 5 minutes. You can try this one. I think we have done this one. Try this one and this one and see whether you'll get absolute acceptable or not. The upper bound and everything. Can you answer me in the chat box one by one? Can you answer me for your second question's answer? Find the, upper bound and find the difference, absolute error. Then see whether it is absolute accurate or not. We have to know this is 5 digits, okay, this question. Also, I need to mention you, this course is all about the calculation. So you have to have a good calculator with you, okay? In exam also, you can use the calculator. So you better have your own good quality calculator with yourself and practice in it rather than, coming to the exam and finding the new calculator. Sometimes you may find difficulties. So it is somehow a little bit expensive. Anyhow, you'll get a nice, Casio or the other good quality. I think you may use already in the stat or anything. Okay. So please find one nice calculator for this course as well. And you can use until the exams and all. Okay. Anyone? Can you answer me for the second question? It's a big. Okay. Okay. Can you give the answer as well? What is your, values? What is your delta? What is your, tolerant? Delta less than what? So how you come to the conclusion? Likewise, the third one also. Okay. What is the delta? What is the delta less than? What is the value? How you come to the conclusion like that? Okay. So 5 digits. Much. 3, 4. Yes. 3, 4. Then in here, okay, wait. To clear this one. So here you can see our W is equal to 5 and N is equal to 3. Therefore, N minus W, 10 to the power N minus W, 10 minus 2. Minus 2. 0.01 will be the tolerance. Then our delta will be, if you take out this one, this much of difference. So 0.0034. Okay. So it is obviously 0.01. Therefore, we can accept. Okay, good. Okay, third one. Third one, what is that? Yes, W is equal to 3, N is equal to minus 1. So 10 to the power N minus W is equal to minus 1 minus 3. This will be minus 4. Okay, 0, 0, 0, 0, 1. Like that. Then the tolerance delta will be 2, 4, 5, 3 digits. So this one. So if you take off 0.00091, isn't it? Yes. Therefore, it is also less than that. Am I right? Okay. This is absolute chopping error, delta. So 0. How many? 3 zeros. So 0.00091 and 0.00091. 3. Okay, 4. Just 4. 0.0001. Yeah, what do you think? 2, 3. Which one? Is a great? Someone put greater than. What is that? So for the third one, we have 0. 0.00 34 less than 0.001. Okay, that is okay. This one 0.003 digit, no? So n will be -1, w will be 3, so minus 4. So 0, 0, 1. Am I right? 1, 2, 3, 4. Yes. And this one 0, 0, 0, 9, 0. Okay. So it is a little bit more than, no? I think this point is 1, this point is 9. So which one is greater? I think this one is greater, no? So if it is greater, then we can't accept. Yeah, good. So check your answer. I don't know. I don't have the answer, but you can check. I think you got the idea. Okay. Okay, let's continue. So that is all about the chopping. Okay, chopping errors. Okay, yes, what is this? Yeah, this one is the answer. Okay. So write nicely, like this is how you have to answer the questions. Okay, so write the solution way of writing, how it has written. Okay, first of all you have to write the question. Okay, the question is like this. This is a question from this. This is my floating point x star, and taking the 4 digits, the answer will be this one. And then what is the w, what is the 3, n. Then find the absolute chopping error bounded by this much, and the absolute chopping error is this much. Therefore this is less than this one. Therefore this is how you have to answer in the exams. Okay, so write down and copy this one quickly. Shall I continue? Okay, this is how you have to answer the question number 2 and 3 as well. Okay. Okay. I have prepared one homework quiz for you for this exercise. The things we are doing in online, so there's no. I don't like you to submit me these homework quizzes through email or anything, because I don't have time to see those things. But what I feel is you have to do it anyhow. Okay, so we can discuss in the next class, or if any possible, we can discuss the questions. But only thing is we have to have it. But when we are coming physically, we will have something for this. Okay, so you have to do it anyhow, but no need to submit now itself. Okay, so anyway, after the session finished, or for exams, or even for the continuous assessment also, I am expecting you to do is as a physical one. Okay, when you are coming for the practical sessions or any exam period, I will have your continuous assessment as a physical one, okay, rather than online one. So I prefer the physical exercise exams. So even after we finish each chapter, we will have the continuous assessment at last when you are coming as a physical for your practical time. So for any case, you will come as a physical in the university. So that time only I will have your continuous assessment, as well as I will check your homework quizzes as well. So you better take one, do separately, or take one CR book and do one by one. So I will have homework quizzes time to time when one, section finish. So rather than you write separate, you write as a booklet. Okay, take one 40 page or any kind of page CR book and write it. Okay, write like a book, like homework quiz 1 and finish everything, and 2 like that. Okay, so you can write the question answer like that. So it will be helpful for you to study in the exam period as well. So I will send this homework quiz later in the WhatsApp. Okay, so let's continue our things. Okay, likewise the chopping off, the computational error. Next one is rounding off. This is very familiar for us even in the school level. Okay, so let's see that one. Next one is a rounding off. First one, the computation under the computational error. So computational error has two algorithm. One, chopping. Next one is a rounding off. Okay, so let's see what is we have seen. Chopping. Chopping means ignoring the part after the W. So what is the rounding off? So let's see. Here, to keep the correct number of significant figures, so you know what is significant figure. So go back and refer the significant figures very carefully. So numbers must be rounded off. Then the discarded digits is called the remainder. For example, we'll see what it is actually the rounding off. So remaining numbers we called as a remainder. Okay. The discarded digit. Discarded means take off, deleted. So it can be deleted. Okay, take off. Those values we called as a reminder of this significant figures. Okay, so there are 3 rules we can have to find out the rounding off error. So first one, this is very familiar for us because we have studied this in the school level also. Okay, so first rule, if the remainder is less than 5, drop the last digit. So I think in your module, I made a mistake in here, 5.3, 5.8, other way around. Okay, please correct it also. There's a mistake. Okay, so what it says is the remainder means what? For example, 2, 3, 4, 5, 6. So we want to round off to 1 decimal point. So this is a 1 decimal point. So if you wanted to round off here, so this is the remainder part, isn't it? So discarded part, this is the remainder part. In here, this value is less than 5. 4 is less than 5, no? So if it is so, you have to drop the last digit. So you have to take out this one and just write the 5.3 only. Okay, we know, you know these things. So 5.3, 4 is the maximum. 4, maybe 4, 3, 2, 1, any number. You have to drop it out and write this one until first decimal point. So what do you think for next one? Okay, let's see the next one and see, come to that. Okay, next part is rule number 2. If the remainder is greater than 5. So this one we know. Increase the final digit by, I think in the module I have put something, I think it's a wrong one. This one I put like 5.8, this one 5.3. Please correct it take out and correct the things. Okay, if you print it or written by that. Okay, so next one, if the remainder is greater than 5, see there. So if you're rounding off to one decimal point, this is one decimal point. The remainder is, this is the first digits of remainder. So this is deciding the rounding off. So if this is 9 greater than 5, no? So if it is greater than 5, the final digits, increase the final digits by 1. So this we have to add 7 plus 1. So 7 plus 1 is 8. So that's why we got the 5.8. So similarly, there is one more rule. If the remainder is exactly 5. So we have seen what is the idea of less than 5, greater than 5. Okay. So what it is for equal to 5. Okay. Less than 5. Okay. Greater than 5. Okay. Okay, if it is equal to 5, there is some rules. Okay, that's exactly 5. The last digit to be close to even numbers. Okay, so we miss, okay, our session also again gonna finish within 10 minutes. So you can join again, okay? Okay, that's fine. So next one, closer to even number. We have studied this different way in our school level. Anyway, everything is same, okay? This is prevent rounding bias. So why we are doing this one? To prevent our rounding biases, rounding errors, okay? Remainder from 1 to 5 be rounded down half the time, and remainder from 6 to 10 be rounded up to the 1/2. For example, let's see this example, okay? If you see that, you'll understand. For example, 3.55. So this, if you wanted to round off to the first decimal, so this is 5 now. So which is deciding is about this one. Okay. So I think in the school level time we have studied, if it is this one is odd number, we have to add. If this is even number, for example 6, 5, if it is even number, we have to keep it as it is, like that. So similar way, but what they are saying is, for example, if it is 5, this one is, if you add 1, 5 plus 1, this is 6, no? This is even number. So if you add 1, if it is giving even number, you can make it to that one. If you're having 5, this one, when you add to this one, 6 plus 1 is equal to 7, no? 7 is not a even number. Therefore, you have to keep it as it is. So that's what they say, closer to even numbers. Okay. So in any way, you can understand this one. If you are having, if you can get the even number by adding 1, you can add that one. If you are getting odd number, you have to keep it as it is, 3.6. Okay, that's the idea. So similar to our school level ideas. Okay, no worries. Okay, let's see one note. Okay, similar wise for the, chopping errors bounded one. Here also we have one upper bounds. Okay, this upper bound is, so what do you think this one? When you see this one, what do you feel? Earlier for our chopping, we have the absolute error is 10 n minus w and relative error is 1 minus w. Here we have, what is this? Half times. So then what do you think? The chopping error is? This idea. Can you chat me? Simple, no? Simple things. Can you answer me what it chopping? This one. This one is, what do you feel the differences? Can you answer me for this question? Yes. Yes, good. Yes, the others. Everyone should answer me. Yes. If you answer me only, I can consider you all are attending my lecture. Yes. Yes, good. Yes, the others. Only 3 answering. 100% are there. Only 3 answers, 4 answers. Okay. Okay, anyway, this is obvious, isn't it? This is a half time of this one. So this is very easy for you to remember. Okay, so chopping errors bounded, upper bound will be half times for the rounding error. Rounding errors. One, both, okay? Even the absolute error and the relative error, both are half time of this one. So we don't need to do the example here because everything's same, but we can do that, okay? And all right, okay. Let's consider this one. What else I have? Okay, one more error, last error, okay? After finishing this one, we are ending our session 1 of chapter 1, okay? Number system and errors. So we almost finished everything. This is the last part, okay? So if you are interested, okay, I think, yeah, you can study this one first. Okay, the last part, truncation error. So you have to know we have seen 5 kind of errors already. So you have to go back and check what is 1, 2, 3, 4. This will be the 5th one. Okay. Truncation error. This will be computational error, error measurement, everything. Okay. Uncertainty and limitation like that. Okay. Check all the errors and understand it. Okay. Now let's see what is truncation error. So what do you think? The name itself is talking something, no? Truncation means, I think you may heard this earlier as well too. Truncation errors? Anyone? Even within seeing this also you can answer me. Truncating means what? So many STED people in physics, all the other subjects also having this kind of term words, no? What do you think truncating means? Answer me, please. Yes, I get one answer. Where's the others? Everyone listening or sleeping or what happened? Please answer me. One more. Approximate, cutting and shorting. Error comes by okay, good. Okay, that's enough. Anyway, truncation error means defined as the error created by truncating, approximating. Truncating means approximation. A mathematical procedure. For example, when we, if there is infinite number of values, for example, pi is equal to, it's a, very famous one, 3.14, something like that. If we don't need this much, so we are cutting this much, then this much of error included somehow in our calculation, isn't it? So that's what it says. Okay, if you are approximating some values, it will bring some errors. That's what called as a truncation error. Okay, in the mathematical procedures. So let's continue. That is the error caused by solving. So you can put the important things I have underlined it. You can also, if you've written already the notes, you can underline the things. Okay, that is the error caused by solving not the problem but rather some approximation to it. Okay, so the problem is not error, the approximation is the error. Okay, this usually called a replacement of an infinite process. That's what I say, 3.14 something, it goes up to infinite number. So we are cutting off in somewhere. So summation, integration, infinite process. In this situation, we'll have this kind of errors. Okay. So this is a formula. Approximation error is equal to present error minus previous error. Okay, that's how we are approximating. We'll see the example. Then relative means this error divided by the present approximation. Okay, so the likewise, so relative means you have to keep it in your mind. Earlier also we say absolute means x minus x star. Then this will be the our actual value. Then relative means this delta divided by that x. Okay, this x. Likewise, our approximation error will be present error minus previous error. The relative of that one epsilon a is equal to this error. Let's say this one EA. EA divided by this present value. Okay, anything x like that. Okay, so this is how we find the relative. Okay, let's see example. So I think you have lecture at 3, so I will finish